Hello, everyone. Hope your Wednesday is going well. Today I wanted to do a short lesson on solubility curves. This is basically a continuation of what we were doing on Tuesday. So I'm going to very briefly run through the key idea from Tuesday, and then we'll do new stuff. So the targets for today, remember, I can identify the different parts of a solution, and I can make and interpret solubility curves. So just as a reminder, solutions are homogeneous unless they're saturated and have chunks at the bottom. Also remember the vocab solute and solvent. In a solution, the solute dissolves into the solvent. So salt is the solute and water is the solvent. So we did the lab. You looked at saturated salt and sugar solutions, and you saw the difference between them. And now we're just going to put that into our notes. So this is the new stuff for today. So the first thing we saw in the lab yesterday, an unsaturated solution is not full. So if you can still dissolve more solute, that is unsaturated, because saturated means full. So you can tell when a solution is saturated if you see a pile of undissolved solute at the bottom. Like that's your clue that this solvent has dissolved as much as it possibly can. So like in this beaker up here, since there's no solute at the bottom, we assume this can still dissolve more. So this we assume is unsaturated. Now there's a chance that it is right at the saturation level, and this has dissolved as much as it possibly could. And if we put even a tiny bit more in, it would just fall to the bottom and it wouldn't dissolve no matter how much we stir it. But the chances of that being true are very small. So we can assume this is unsaturated. However, this one here with a giant pile at the bottom, we know that this is a saturated solution. And as a result, it's also heterogeneous. We have different regions with different properties. It's not uniform. Down here, you have a big old pile of salt or whatever this is at the bottom. And up here, you don't have that. It's not the same all throughout. Whereas here, whatever solute is dissolved is perfectly mixed because it's dissolved. So unsaturated, not full. Saturated is full. So today, we're going to be working with solubility curves. Solubility curves basically show how the solubility changes with temperature. How does temperature affect how much can dissolve? So a couple of new words that are on the slide. First, anytime you see the word soluble, or that just means able to dissolve. Salt is soluble in water. Sugar is soluble in water. Lots of things are soluble in water. When you see the word solubility, that's talking about how much can dissolve, the amount. Solubility is a number. So what we saw in the lab yesterday, sugar has a higher solubility than salt. Like 4 times as much sugar could dissolve as salt. And what we find in the lab is that as the temperature increases, for most solid substances, the solubility increases. So to read this graph, you just look, as the temperature increases, the grams of solute, that's how much stuff is dissolved, increases as well. So you notice this word saturated on this line. That's because any point along this line represents the most that can dissolve at that temperature. So if we're at around room temperature, which is 20 degrees right here, if we go up to that line, the most we would expect to dissolve in 100 milliliters of water is maybe about 85 grams. Whereas if we took that same amount of water and we heated it up to 100, then we could dissolve over 160, like 165 grams. So anything along this line is saturated, which means that anything less than that is unsaturated. So if I'm at 40 degrees and I've only added 80 grams, that's under the line. So I could still add more. It would take almost 20 more before I get up to here, and then it's saturated. And if I tried to add more, the extra I add would just pile up on the bottom. Now you'll notice there's this other word up here that we haven't seen before, supersaturated. This is special situation. If you can get the extra to dissolve, then at that same temperature, then it would be supersaturated. It's pretty rare, and it's not going to be the answer most of the time. But if you ever do happen to get a point above the line is supersaturated. So I want to show you two questions like what you might be asked just to practice. Your work time today will be a graph similar to this. It'll have sugar and salt on it, but it's the same idea. So a question might ask, what's the largest amount of KNO3 that could dissolve in 100 milliliters of water at 60 degrees Celsius? So the first thing I want to point out to you, if you ever see something like 100 milliliters of water in the question, they're just telling you that you can use this graph or the reference table. Because if you notice the scale, it's grams of solute per 100 milliliters of water. That's them saying, we're going to focus just on 100 milliliters of water because you can't compare different amounts of water to each other. Like how much salt can dissolve in this much water versus how much salt can dissolve in this much water. Like it's not a fair comparison. So we're going to say, okay, just 100 milliliters, how much water could dissolve at 60 degrees? So the way I would do that is I would find 60 degrees, and then it says, what's the largest amount that can dissolve? To me, that's code word for, oh, that's when it's saturated. Saturated means the most that can dissolve, it's full. So I would go up to the line, and I'd be right here. How many grams is that? I'm gonna have to estimate. To me, it looks just a little above halfway. So I would say something, halfway would be 110, so something like 112. And as long as you're within a couple, you would get credit for that. Another way they might ask it is 120 grams of KNO3, which by the way, KNO3 is just a different kind of salt. 120 grams of KNO3 are dissolved in 100 milliliters of water at 80 degrees Celsius. What type of solution is this? So once again, there's that 100 milliliters of water. They're just telling us we can use this graph. We can ignore that number now. And they're basically giving us a point. They're giving us two numbers, and if we can find that point and where it is on the graph, we know what type of solution it is. So 120 grams of KNO3 would be here. And we follow that over until we get to 80 degrees Celsius. So that point is right there. 120 grams, 80 degrees. And that point is under the line. And since it's under the line, we know it's unsaturated. And if we just add, like we could still add more, and it would dissolve. Not much more, like saturated is up here at like 130 something, 131, 132. So we couldn't add too much more, but we could still add more, which means that it's unsaturated. All right, I hope that was helpful. The assignment is relatively short, 8 questions, and it's based upon a solubility curve for salt and sugar. Hope you all have a great day, and I'll see you on Thursday. Bye.